Unit 2, page 3, for your test review. All right. So we have page 3 covers section 2.3, which was all about using reference angles to find those exact values on the trig functions. And I'm going to go close my door. One moment. Take 2. Here we go. We are finding all 6 trig ratios. So first things first, I'm going to go ahead and draw a little coordinate grid. All right. We need to find all the trig ratios for 135. Now, 135 is going to be in quadrant 2. So this is a 135-degree angle. So if we draw it kind of in our standard position, remember the initial side starts on the x-axis, and then the terminal side ends, somewhere else. So I don't really care about the 135, though. What I care about is this reference angle down here. And to figure that one out, how much is it going to take to get us to 180? All right, so 180 minus 135 gives us 45. So this triangle right here is a 45, 45, 90 triangle. All right. Now in your 45, 45, 90s, keep in mind it is 1, then 1, and then the square root of 2. However, we have to be a little bit more careful, because if you look down at the bottom part, it's actually a -1 because it does go in the negative direction on your graph. So that's just something to keep in mind. They want us to find all 6 trig ratios. So we'll start with the cosine. We know the cosine of 135 equals, so we kind of said there, the cosine was x over r. So this one is -1 over square root of 2, which simplifies to negative square root of 2 over 2. All right. The reciprocal of cosine is the secant. So the secant of 135 is equal to the square root of 2 over -1. Then with sine of 135 is the opposite over hypotenuse. So +1 over the square root of 2, which simplifies to the square root of 2 over 2, which means the cosecant of 135 is the square root of 2 over 1. And then last but not least, the tangent of 135 is equal to opposite over adjacent, which is 1 over -1, which simplifies to -1. Thus, the cotangent of 135 is -1 over 1, which again is -1. So there's all 6 trig ratios there. So we're going to go ahead and do the same thing on number 11. Make another graph, but this time we are looking for 60 degrees. So drawing your standard angle at 60 degrees. That happens to be our reference angle right here. All right. So this is a 30, 60, 90 triangle. So hopefully you remember that one as well. That looks pretty bad. Let me do that again. We have a 60-degree angle right here. So we have a 30, 60, 90 triangle right here. All right, so the shortest side is across from the smallest angle. That has a side length of 1. The side length that's across from the 60 has a side length of square root of 3. And then the hypotenuse has a length of 2. Now, the hypotenuse on these is always positive. The 1 and the square root of 3 are going in the positive direction. So those are also positive numbers. So our triangle is correct here. So now filling out all of the trig functions, trig ratios, we're good to go here. So the cosine of 60 equals the adjacent over the hypotenuse. All right, so that means the secant of 60 is the reciprocal, 2 over 1. All right, the sine of 60 is square root of 3 over 2. So the cosecant is 2 over the square root of 3, which gives us 2 radical 3 over normal 3. And then the last one is the tangent. The tangent of 60 equals square root of 3. We'll try that again. Tangent of 60 is the square root of 3 over 1. So the cotangent is 1 over the square root of 3, which is square root of 3 over normal 3. And that one's finished. Next, find the specific ratio. Make sure to draw the picture for each example. All right, so I only care about sine in this one. I don't care about any of the others. So, but in either case, we still have to draw our graph here. We want a 210-degree angle. That's going to be somewhere down in quadrant 3. So that's a 210-degree angle, but I don't want the 210. I want the reference angle. All right, that reference angle is always a positive number. That is 30 degrees. So that means we have a 60-degree downstairs and then 90-degree. All right, so I think I mentioned it in video 1 here, but if you don't know your special right triangles, your 30, 60, 90s, and your 45, 45, 90s, you really have to make sure you know those well, because those are kind of key for this entire unit. And really this whole class, those things show up all the time. All right, so you got 1, 2, square root of 3, making sure the positives and the negatives are in the correct spot. It's a -1 because it goes down 1 space. Negative square root of 3 because it goes to the left square root of 3 units. All right, so the sine of 210, the sine of 210 is going to be the opposite over the hypotenuse. So sine of 210 is -1/2. And if you don't believe me, throw it into your calculator. The sine of 210, right, it should be -0.5, which that's what it gives us. All right, so we can always check these things. Now, the next one, the tangent of 120. So a 120-degree angle is going to go somewhere right here. That's 120. What is that reference angle? The reference angle is what it takes to get us back to the x-axis. So the reference angle here is 60 degrees. So let's draw this triangle right here. We have a 30, 60, 90. All right, so that means we have a -1, positive square root of 3, and then a +2 on the hypotenuse. And the tangent of 120 is the opposite over the adjacent. So we have the square root of 3 over 1. And just to confirm that, tangent of 120, it's going to be some ugly decimal. All right, but if we plug it in, we have square root of 3 divided by -1. We get that same decimal. All right, so I missed a negative sign here. All right, now we have the secant of 225. Figure out where 225 goes on your graph. It's going to be down in quadrant 3. This is a 225-degree angle. All right, but I want this one. It's 225. That has a reference angle of 45. All right. So here's your 45, 45, 90 triangle where you're going -1 units down, -1 units to the left, and square root of 2 units diagonally. Secant kind of matches up with cosine. The cosine is the adjacent over the hypotenuse. So the secant is the hypotenuse over the adjacent. So we have square root of 2 over -1. All right. Then it's continuing down the line. We have a cosecant now. 240. That ends up in quadrant 3. So here's a 240-degree angle. we need this reference angle right here, which is 60. Right, it takes 60 degrees to kind of get us back to the x-axis. So here's a 30, here's a 90, and once again, filling it all in. -1, negative square root of 3, and then a 2. So cosecant matches up with sine. Sine is the opposite over hypotenuse. So this one is the hypotenuse over the opposite. So we're going to have 2 over negative square root of 3. We don't like that. Let's rationalize it. We have 2 square root of 3 over a normal -3. Okay. Next one is the cosine of 30. And so here is your 30-degree angle, 30, 60, 90. Square root of 3, 1, 2. The cosine is the adjacent over the hypotenuse. So this one equals the square root of 3 over 2. And the last one is the cotangent of 45. So 45-degree angle. It's making your triangle. 45, 45, 90. That is a 1, and a square root of 2. So the cotangent is the reciprocal of the tangent. Tangent is opposite over tangent is opposite over adjacent. So the cotangent is the adjacent over the opposite. 1 divided by 1, of course, is 1. All right. Now, special cases where it falls right on an axis. So a cosine of 90 degrees. So if you think about where 90 degrees is, 90 degrees is somewhere, on the y-axis, right? So one thing to keep in mind here is that's an ordered pair. It's x, y. All right, it's x units to the left and right, and it's y units up. I don't know what number it is specifically, and it turns out it doesn't matter. All right, but we know no matter what on this case, no matter how far up and down it is, the x value here is always 0. All right, because it's not x units to the left or to the right. It's right on that y-axis here. So x is always going to be 0 in this case. Y can be any number you want, right? It's in the positive direction, so it doesn't matter. I'm just going to call it 1. Right? So we need to figure out the radius. Right? So on all of these problems, we know that the radius squared equals x squared plus y squared. Right? So if we just wanted to plug that in, we know the radius squared is 0 squared plus 1 squared. Right? So radius squared equals 1, so the radius is equal to 1. All right, so now the cosine. Cosine of 90. We know the cosine matches up with x over r, which equals 0 over 1, which is 0. And again, if you're not sure, plug it in. All right? Grab a calculator. Make sure it's in degrees. Type in the cosine of 90, and it should spit out a 0. All right, which it does. Next one. Cosine of 180. So plot 180 on here. That is going to be somewhere over here. So let's just figure out what x and y are. All right. So x does not matter, but it will be in the negative direction. So I'm going to say x is -1. You can make it whatever you want. I'm using -1. The y value, however, is 0. All right. So we know, once again, r squared equals x squared plus y squared. So r squared equals -1 squared plus 0 squared. I'm going to skip a step and say r is 1. All right. So x is -1, y is 0, and r is 1. So again, the cosine is x over r again. So the cosine of 180 equals -1 over 1, which is -1. And just to double check, cosine of 180, there's your -1. All right, last but not least, tangent of 270 degrees. A 270-degree angle is going to be on your y-axis in the bottom. All right, so this x, y, think about which order pair doesn't matter. X is going to be the value that stays 0 because it's 0 units left and right. And then y, I'm going to use -1. And then r, in this case, I'm going to skip a step, but r is 1 here. All right. So the tangent of theta, I'm running out of room. We'll say the tangent of 270 equals, that's y over x. So y over x is 1 over 0. You can't divide anything by 0, so this one is undefined. Right. So when you type this in your calculator, you do the tangent of 270, you're going to get an error. It'll probably say divide by 0 or undefined or something, domain. All right, so it says error domain because you cannot divide anything by 0. That doesn't work in math. All right, but there you go. That is page 3 on your test review. You got one more. Hang in there. We are almost done.